All right, let's look at this problem. So we got a 60 kilogram and a 90 kilogram skydiver, and they're both going head first. Now, what we're trying to figure out is how long it will take them to pull the parachute, or how long it'll take them to drop from 6,000 meters to 1,000 meters. So first thing we need to do is find out how fast they're going. So I think most people might say that the 90 kilogram skydiver is going to fall faster, given that they have the same surface area, and I'd be right. So let's go ahead and calculate how fast each one is going. They're going to have different speeds. So they're going head first, so they're going like this, and with the hair falling down like that. Okay, so she's going super fast down, and let's calculate everything that she needs. So first of all, the force of gravity is pulling down, and the force drag, or the air resistance, is pushing up, right? And then right here it says something about terminal velocity. So terminal velocity is when you're not accelerating downwards any faster. So you're not going downwards any faster. So that's when the force of gravity is equal to the force drag. So let's go ahead and set that up right here. So force gravity is equal to force drag in magnitude. Okay, so let's go ahead and put this down here. So remember, the force of gravity is just mass times acceleration. So I'm going to go ahead and replace this force drag with force of gravity, and then we get 1/2 QCAV squared. And then I'm going to replace it again with mass times acceleration, which is also 1/2 QCAV squared. Now the mass, I'm going to do the 60 kilogram first. So that's 60. Acceleration due to gravity is 10. So we get 1/2 Q. Q on Earth is just 1. And we know that just from looking up this Q value up here. So we can see that it's 1 on Earth and 0.55 on Mars. And then that's the, here, I'm going to show you. So it says right here that Q is the density of the fluid. So right there. So make a guess on what the density of that fluid would be. Yeah, it would be much higher than 1. Okay, so let's go ahead and look here again. And we get 1. Now we need to look up this C value. So C is the orientation, or the object that we're looking at. So we look at a Toyota Camry here, Ford Focus, skydiver foot first, and a skydiver horizontal. So we're definitely dealing with the skydiver, but which one? I think we should use the foot first skydiver, because that's most similar to our situation, which is the head first. Head first. Okay, so let's use, it says 0.7. So 1. .7, and then the area looks like it is 0.14. So then we're going to multiply that by 0.14, and then we get the V squared. All right, so this is going to end up being 600. And on this side, it'll be 0.5 times 1 times 0.7 times 0.14, 0.049 V squared. Okay, divide both sides by 0.049. And we get 12,000 244 or 45. Okay, so that implies, so after we take the square root, that v equals plus or minus, taking the square root of both sides now, 111 meters per second. So plus or minus. Now, which one is it going to be? Is it going to be plus or is it going to be the minus? And yeah, make a guess real quick. And it's going to be the minus, right? Because this skydiver is definitely going downwards. So negative 111 meters per second. And there we go. That's our answer for, well, that's only halfway there. Okay, so now we're going to repeat this again for the 90. So right here we end up with force drag equals 1/2 qc AV squared. That's going to be mass times acceleration, 1/2 qc AV squared. The mass is 90, acceleration due to gravity is 10. We get 1/2 q, it's on Earth. C, it's a skydiver going head first or foot first. It's about the same thing. So we get a 0.7 again. So it looks like that's all the same so far. And then A, that's 0.14 because it says they have the same surface area. And then we get a v squared. So we get 900 equals 0.049 because I'm remembering it from the previous problem, the previous one. Divide both sides by 0.049. And we get 18,367. Take the square root of both sides, and we get plus or minus 136. Now again, make a guess, positive or negative. You are right. It is negative 136 because this diver is going down as well. And there we go. We get the two values. Now, we want to know how long it'll take them to pull their parachute. Let's go ahead and read this question again. How long, right here, how long will it take for each skydiver to pull the parachute? And they're going to pull the parachute at 1,000 meters. So they have to drop 5,000 meters. Now, I'm going to purposefully make a little mistake here. Now, see if you can catch me. All right. So, if we use the equation, velocity is distance or change in position over time. We have the velocity, right? We have the velocity, we just found them both. We know the change in position, that's 5,000. And then that'll allow us to solve for the time, right? Now, I've already kind of made a mistake here just by the way I've been talking about this. All right, so we get, for the first one, V equals change in position over time. So velocity is negative 111 equals change in position, which is 5,000, all over time. I'm going to solve for time real quick. Negative 111 t by multiplying by t on both sides. Now I'm going to divide by 111. And I get negative 45. Now that doesn't make sense because that means that they pulled the parachute 45 seconds before they jumped out of the airplane, which makes no sense, right? So can you find the mistake I made? It's right here. The change in position is actually negative 5,000, right? Because they dropped 5,000 meters. So we got to change all these to a negative. So when we divide by 111 on both sides, yeah, let's do that again. When we divide by negative 11 on both sides, we get a positive number. So t is positive 45 seconds. Okay, so that's how long it takes for the skydiver, the 60 kilogram skydiver, to pull their parachute. Now, how long does it take for the 90 kilogram? So velocity is change in position over time. So velocity is negative 136 equals change in position, drop 5,000 meters all over time. But we can't make the same mistake. They actually dropped 5,000 meters, so that's negative 5,000. So multiply both sides by t, 136t equals negative 5,000. Divide by 136 on both sides. And we get 36.8. Or let's just say 37 seconds. Boom. So it makes sense that because the heavier skydiver is going faster, they need to pull their parachute quicker so they don't go hitting the ground. All right.